Soil pressures are like hydrostatic loads. If you recall, hydrostatic loads describe motionless fluids. They increase with depth from the free surface, but the horizontal loads induced by the gravitational forces are smaller than the vertical ones for any given depth. The pressure equation in the vertical direction is PV equals gamma times H. PV is the vertical pressure, gamma is the weight density, and H is the height. This equation is also written as rho GH, where rho is density and g is the gravitational acceleration of 9.8 meters per second squared. Just to clarify, gamma is equal to rho GH. The pressure equation in the horizontal direction is pH equals K times gamma times H, where pH is the horizontal pressure and K depends on the soil properties and loading history. This equation can also be written as K rho GH. For sand, its weight density is 15 kilonewtons per meters cubed and its K value is 0.4. Plot the vertical and horizontal pressures on the same graph at a depth of 2 meters. First, let's recall the equations from the previous slide. There are two graphs below. The only difference between the two is that pressure and depth have switched x and y coordinates. To find the vertical pressure, it's PV equals gamma times H, which is 15 kilonewtons per meters cubed times 2 meters, which gives you 30 kilopascals. To find the horizontal pressure, it's pH equals K times gamma times H, which is 0.4 times 15 kilonewtons per meters cubed times 2 meters, which gives you 12 kilopascals. Let's start with the graph that has depth on the x-axis. Starting with vertical pressure, it had a depth of 2 meters and a pressure of 30 kilopascals. Since pressure changes linearly with depth, we can draw a straight line from 0 kilopascals to 30 kilopascals to show the change. Then we can write the coordinates. For horizontal pressure, it had a depth of 2 meters and a pressure of 12 kilopascals. We can draw the linear line and write the coordinates. Using the same data, we can create the other graph with pressure as its x-axis. This graph helps us visualize how depth affects the change in pressure linearly. When we think of depth, we normally think of digging into the ground. That's why the depth and pressure axes are switched, so we can visually see depth going into the ground.